Hello, my dear students. Today we are going to continue chapter 2, which is chemical analysis. We are going to discuss revision on chemical calculation, and then we are going to discuss the quantitative analysis and explain in details the volumetric analysis. So let us start. Now, my dear students, we are going to continue our revision on chemical calculation. The relation between the density of the gas and molar mass. As shown on the screen, the density equals molar mass over 22.4 liter. For example, calculate the density of oxygen gas at standard temperature and pressure, where the atomic mass of oxygen equals 16. Here the solution is molar mass or mass of 1 mole of oxygen equal 2 times 16 equals 32 gram. Then the density equal molar mass over 22.4. So 32 over 22.4 equals 1.43 gram per liter. Now the relation between the mole and the solution. We have to define the molar solution. It is a solution where each liter contains 1 mole of solute. As shown on the screen, the concentration, which its unit is mole per liter or molar, equal number of moles over the volume in liter. So, since the number of mole equal mass of the substance over molar mass, so the mass of the substance equal concentration times the volume times the molar mass. So, as shown in the following triangle, the mass can be calculated by multiplying the concentration times the molar mass times the volume in liter. For example, calculate the concentration of sodium carbonate solution resulting from dissolving 0.1 mole in 250 milliliter water. The solution. The concentration equal number of moles over volume. So 0.1 over 250 times 10 to the power negative 3 to change it to liter, it will be 0.4 molar. Now we are going to discuss the weight percentage of elements. The element weight percent equal element mass over molar mass times 100. For example, calculate the percentage of oxygen in sodium sulfate, where the atomic mass of sodium 23, sulfur 32, oxygen equals 16. Solution here. 1 mole of sodium sulfate contains 4 moles of oxygen. So the percentage of oxygen, mass of 4 moles of oxygen over the molar mass of sodium sulfate times 100. So the percentage of oxygen equal 4 times 16 over 32 times 2 plus 32 plus 16 times 4 times 100, it will be 45%. Another example, iron oxide ore contains 30% hematite. Calculate how many tons of ore needed to form 1 ton of iron, where the atomic mass of iron equals 56 and the atomic mass of oxygen equals 16. Solution. 1 mole of iron 3 oxide contains 2 moles of iron. So 56 times 2 plus 3 times 16 equal 160 gram contains 2 times 56 equal 112 gram iron. So 160 ton of iron 3 oxide gives 112 ton of iron. Then X ton of iron 3 oxide gives 1 ton of iron. So mass of iron 3 oxide equal 1 times 160 over 112, so equal 1.43 ton. So as it is 30% ore, it means 100 ton for the ore contains 30 ton pure iron 3 oxide. So X ton iron 3 oxide ore contains 1.43 ton of pure iron 3 oxide. So X ton of iron 3 oxide ore equal 1.43 times 100 over 30 equal 4.7 ton. Another example, siderite ore contains 40% siderite. Calculate how many tons of iron can be produced from 5 tons of siderite ore, where the atomic mass of iron equal 56, carbon equal 12, oxygen equal 16. Solution: for every 100 tons of iron 2 carbonate ore, it contains 40 tons of iron 2 carbonate. So for 5 tons of iron 2 carbonate ore contains X ton of iron 2 carbonate. So X ton of iron 2 carbonate will be equal 5 times 40 over 100 equal 2 ton. Here 1 mole of iron 2 carbonate contains 1 mole of iron. So 56 plus 12 plus 3 times 16 gram iron 2 carbonate contains 56 gram iron. So 116 gram of iron 2 carbonate contains 56 gram iron. Then 116 ton of iron 2 carbonate contain 56 ton of iron. So 2 ton of iron 2 carbonate contains X ton of iron. So by getting the ratio, mass of iron equal 2 times 56 over 116. So it will be 0.965 ton. Here, my dear students, the weight percentage of compounds. The mass percent of compound in impure sample, compound mass in sample over mass of impure sample times 100. For example, on oxidation of 0.5 gram of magnetite ore Fe3O4 into iron 3 oxide, 0.411 gram of iron 3 oxide are produced. Calculate the percent of black oxide Fe3O4 in the ore, where the atomic mass of iron equal 56, oxygen equal 16. Solution: here's the equation of the reaction. When the magnetite ore is oxidized into iron 3 oxide, this iron 3 oxide here, the equation will be balanced as shown on the screen. So means 2 mole of magnetic iron oxide gives 3 mole of iron 3 oxide. So 2 times 3 times 56 plus 4 times 16 equal 464 gram. That gives 3 times 2 times 56 plus 3 times 16 gives 480 gram. So X gram here can be 0.411 gram. So X gram will be 0.411 times 464 over 180 equal 0.3973 gram. So the percentage of iron, magnetic iron oxide, will be 0.397 gram over the mass of the ore, 0.5 times 100, it will be 79.46%. Another example, calculate the percentage of chlorine in 2 gram of impure potassium chloride, which reacts with silver nitrate to get 4.628 gram of silver chloride, where the atomic mass of potassium equals 39, chlorine equals 35.5, and silver equal 108. Here the solution is the balanced equation of the reaction. KCl plus AgNO3 gives AgCl plus KNO3. So 1 mole of potassium chloride gives 1 mole of silver chloride. So 1 times 39 plus 35.5 equals 74.5 gram potassium chloride gives 1 times 108 plus 35.5 equals 143.5 gram silver chloride. So X gram potassium chloride gives 4.628 gram silver chloride. So X equals 4.628 times 474.5 over 143.5 equal 2.4 gram. As we know that 1 mole potassium chloride contains 1 mole chlorine. So 1 times 39 plus 35.5 equals 74.5 gram potassium chloride contain 1 times 35.5 gram chloride. So 2.4 gram potassium chloride gives x gram chlorine. So x gram chlorine equal 2.4 times 35.5 over 74.5, it will be 1.14 gram. So percentage of chlorine equal 1.14 over 2 times 100 equal 57%. Now, my dear students, we are going to discuss the quantitative analysis. And we are going to discuss first the volumetric analysis. It is the method used to determine the concentration of the known solution through measuring the volume of the standard solution that's completely consumed by the analyte during titration process. So, what do we mean by the standard solution? It is the reagent solution of accurately known concentration. So, what do we mean by titration reaction? It is the process of measuring the amount of the reagent, which is called standard solution, that is completely consumed by the analyte. Two types of titration reaction. Neutralization reaction, where it is used to determine the concentration of acid or base. Oxidation reduction reaction, that is used to determine the concentration of the oxidizing or reducing substance. And the precipitation reaction. It is used to determine the concentration of the product that is slightly soluble in water, that we call precipitate. Now we are going to discuss neutralization reactions. This reaction occurs when an acid reacts with alkali, it gives salt and water. So, to determine the concentration of an acid, we have to use an alkali that is the standard solution, such as sodium hydroxide or sodium carbonate during the titration process. Or to determine the concentration of an alkali, we have to use an acid as a standard solution, such as hydrochloric acid during titration process. Now, what do we mean by end point or neutralization point? It is the point at which the neutralization reaction is completed. Now, what is meant by indicator? It is a substance that changes its color in acidic or an alkali medium. So the indicator is used to detect the end point of the neutralization reaction. The types of indicators. As the screen shows this table of comparison between different types of indicators and their color in the acidic medium and alkaline medium. First one is the methyl orange. Its color in acidic medium is red, while in basic medium is yellow. Second one is the phenolphthalein, has colorless solution in acidic medium and red color solution in alkaline medium. Litmus has red color in acidic solution and blue color in basic solution. And last one is blue bromothymol blue. Here its color is yellow in acidic medium and its color is blue in alkaline medium. So we have some give reasons on this table. First one, the basic solution is not used to distinguish between the litmus solution and the bromothymol solution? The answer, because each one has blue color in basic medium. Another give reason. The hydrochloric acid cannot differentiate between methyl orange and litmus, because each one has red color in acidic solution. Another give reason. Phenolphthalein is not used to detect the acids, because it is colorless in acidic medium. Now we are going to discuss neutralization reaction experiment. Here, the determination of the concentration of sodium hydroxide solution on titration with a standard solution of 0.1 molar hydrochloric acid. The steps here: put 25 milliliter of sodium hydroxide in a conical flask using pipette. Then add 2 drops of phenolphthalein so the color of the solution turns red. Add hydrochloric acid from the pipette till the color of the solution turns colorless. Here, the observation: the volume of the hydrochloric acid added at the end point equal 21 milliliter, as the following animation will show. As shown on the screen, we measure the 25 milliliter of the alkali into the flask, and then fill the pipette with 0.1 molar hydrochloric acid till we reach the 0 mark, and then we add the phenolphthalein to the sodium hydroxide solution. Then, by adding the hydrochloric acid from the pipette to the alkali until the color of the solution turns colorless, as the phenolphthalein color changes into colorless in acidic or neutral medium, so the reading of the pipette 21 milliliter. Now the calculation steps for the experiment. The number of added moles of hydrochloric acid equal concentration times volume in liter, so equal 0.1 times 21 over 1000, it will be 2.1 times 10 to the power negative 3. So from the equation of the reaction, hydrochloric acid plus sodium hydroxide gives sodium chloride and water. So as 1 mole of hydrochloric acid reacts with 1 mole of sodium hydroxide, so 2.1 times 10 to the power negative 3 mole of hydrochloric acid reacts with 2.1 times 10 to the power negative 3 mole sodium hydroxide. Since the volume of sodium hydroxide equal 25 milliliter, so equal 25 times 10 to the power negative 3 liter, so the concentration of sodium hydroxide equals number of moles of sodium hydroxide over the volume in liter, so it will be 2.1 times 10 to the power negative 3 over 25 times 10 to the power negative 3, so equal 0.084 mole per liter. Now we can use the following relations to simplify the calculation. M1 V1 over Na equal M2 V2 over Nb, where M1 concentration of the acid in molarity, and V1 is the volume of acid in liter, and Na is the number of moles of acid from the equation of the reaction, and M2 the concentration of the alkali used in molarity, and the V2 is the volume of alkali used in liter. Here the Nb equals the number of moles of alkali from the balanced chemical equation. So by applying the rule, so 0.1 times 21 times 10 to the power negative 3 equal m times 25 times 10 to the power negative 3, So concentration of sodium hydroxide equal 21 times 0.1 times 10 to the power negative 3 over 25 times 10 to the power negative 3. So equal 0.084 mole per liter or molar. My dear student, notice that we can use the following relations during neutralization reaction. Number of moles of acid over Na equal number of moles of alkali over Nb. Or we can use mass of the acid over molar mass times Na equal mass of the alkali over molar mass of alkali times Nb. So examples. Here in the titration of 25 milliliter of 0.5 molar hydrochloric acid, exactly neutralize 20 milliliter of calcium hydroxide. Find the concentration of calcium hydroxide. The solution: you must write the balanced chemical equation at first. 2HCl plus calcium hydroxide gives calcium chloride plus 2H2O. Here for HCl, concentration of hydrochloric acid M1 equals 0.5 molar, volume of hydrochloric acid equal V1 equal 25 times 10 to the power negative 3 liter, number of moles of HCl Na equal 2. For calcium hydroxide, concentration of calcium hydroxide equal M2 and it is unknown. And here the volume of calcium hydroxide V2 equal 20 times 10 to the power negative 3 liter, and number of moles of calcium hydroxide Nb equal 1. Now we can use the relation M1 V1 over Na equal M2 V2 over Nb. So by substitution, 0.5 times 25 times 10 to the power negative 3 over 2 equal M2 times 20 times 10 to the power negative 3 over 1. So the concentration of calcium hydroxide M2 equals 0.5 times 25 times 10 to the power negative 3 over 2 times 20 times 10 to the power negative 3. So equals 0.312 mole per liter. Find the molar mass of a base MOHO2, that's 2.05 gram of it, react with 24 milliliter of 1 molar hydrochloric acid. Solution: you must write the balanced chemical equation at first. 2HCl plus MOHO2 gives MCl2 plus 2H2O as the screen shows. So for hydrochloric acid, concentration of HCl equal 1 molar, volume of HCl equal 24 milliliter equal 24 times 10 to the power negative 3 liter, number of moles of acid in the equation equal 2. For the base MOHO2, molar mass is unknown. Mass of MOHO2 base equal 2.05 gram, and the number of moles in the balanced equation equal 1. So by applying the relation M1 V1 over Na equal mass of the base over its molar mass times Nb. So 1 times 24 times 10 to the power negative 3 over 2 equal 2.05 over molar mass times 1. So the molar mass 2 times 2.05 over 24 times 10 to the power negative 3 equals 170.8 gram. Another example, 3 gram monobasic acid was dissolved in water and then the solution completed to 250 milliliter. 20 milliliter of it was neutralized with 15 milliliter caustic soda of 0.2 molar. Calculate the molecular mass of the acid. Solution of the problem: you must write the balanced chemical equation at first. HX plus NaOH gives NaX plus H2O, as the acid is unknown. So for the acid, the concentration is unknown, and the volume is 20 times 10 to the power negative 3 liter, and the number of moles in the equation is 1. For the base, concentration equals 0.2 molar, the volume of sodium hydroxide equals 15 times 10 to the power negative 3 liter, and the number of moles equal 1. So by applying the relation M1 V1 over Na, equal M2 V2 over NB. So M1 times 20 times 10 to the power negative 3 over 1 equals 0.2 times 15 times 10 to the power negative 3 over 1. So concentration of the acid equal 0.2 times 15 times 10 to the power negative 3 over 20 times 10 to the power negative 3 equals 0.15 molar. As the mass of the monobasic acid in the problem is 3 gram and the volume that 250 times 10 to the power negative 3 liter, so we can find the molar mass of the acid by getting the relation molar mass equal mass over the volume times concentration. So 3 over 0.15 times 250 times 10 to the power negative 3 equals 80 gram. Mixture from solid substances contains sodium hydroxide and sodium chloride. 0.1 gram from it is titrated by 10 milliliter from 0.1 molar hydrochloric acid. Calculate the percentage of sodium hydroxide in the mixture. Solution. The hydrochloric acid is used to neutralize sodium hydroxide, so HCl plus NaOH gives NaCl plus water. So the number of moles equal concentration times volume, so 0.1 times 10 over 1000, it will be 0.001 mole. So from the equation of the reaction, 1 mole of hydrochloric acid reacts with 1 mole of sodium hydroxide. So 0.001 mole of hydrochloric acid reacts with 0.001 mole of sodium hydroxide. So the mass of sodium hydroxide in the mixture equal number of moles times the molar mass. So 0.001 times 23 plus 16 plus 1 equals 0.04 gram. So the percentage of sodium hydroxide in the mixture 0.04 over 0.1 times 100 equal 40%. My dear students, we have reached to the end of our program today. I hope you understood all the points and the problems that we discussed today. So till we meet again, my best wishes for you.